Hello there. In this video we're going to look into a particular application of logarithmic functions, in particular the pH and the pOH of a particular substance. So, as you may or may not already know, the pH is defined to be equal to the negative logarithm base 10 of the concentration of hydronium in a particular substance, and the pOH of a particular substance, so pOH, is defined to be equal to the negative logarithm, base 10, of hydroxide in that particular substance. So in this video, we're going to talk about a little bit more on how to interpret these things and look at a few examples of them. Alright, so as already mentioned, this notation here with the bracket H plus is going to be your hydronium concentration. And bracket OH minus corresponds to your hydroxide concentration. And if you've studied some basic chemistry, you should know that there is a relationship between hydronium hydroxide and water. All right? And that connection is the following. So the equilibrium constant for the ionization of water is equal to 10 to the minus 14 approximately. All right? So if you don't know what that means, that's okay. This is just to pretty much bring together the chemistry and the mathematical world. But in the realm of mathematics, this means that the product of the concentration of hydronium with the concentration of hydroxide must be equal to 10 to the minus 14. So that can be sort of like a corollary. So in the realm of our mathematical discussion, let's start here. Let us see if we can figure out a connection between the pH and the pOH of a particular substance. So what I'm going to be doing is I'm going to be taking the logarithm of both sides of this equation. So I'm going to have the log base 10 of the product of hydronium and hydroxide. And that's going to be equal to the log base 10 of 10 to the minus 4. So on the left-hand side, using our properties of logarithms, this is going to be equal to the log of the hydroxide concentration, hydronium, plus the logarithm of our hydroxide concentration. And that's going to be equal to minus 14. Right? I lost my 1. Okay. So now what I'm going to do is I'm going to multiply both sides by negative 1. So I'm going to have minus log of hydronium plus negative log of hydroxide concentration must be equal to minus 14. Right? The opposite of that. So this, by definition, so that's going to be pH. This right here is pOH, by definition. And that must be equal to 14. Right? And that's for any substance. Great. All right, so let's start off with an example of this. So let us suppose that the hydronium concentration for a particular substance is going to be 10 to the minus 4.3 molar. Right? So what is the hydroxide concentration for this particular substance? All right, so we can use this property that we just derived. So if our concentration is 10 to the minus 4.3 molar, then the pH for this particular substance is going to be equal to the negative logarithm of the concentration, so 10 to the minus 4.3. So that's going to be equal to 4.3. All right, so that's the pH of this particular substance. So if you don't remember, if the pH for a particular substance is less than 7, this is going to be an acid. Okay. All right, so if we know the pH, then what about the pOH? So since pOH is going to be equal to 14 minus pH, this is going to be 14 minus 4.3, and that's going to be equal to 9.7. So that's the pOH, right? So remember what pOH is. So pOH is going to be equal to the negative logarithm of the hydroxide concentration, so OH minus, right? So we already know what pOH is, right? So pOH is 9.7, so 9.7 must be equal to the negative logarithm of the concentration of OH minus. So negate both sides, so we have negative 9.7 is equal to the log of OH minus, and we can easily solve this logarithmic equation by exponentiating both sides by 10. So that means the concentration of hydroxide in this particular substance is going to be equal to 10 to the minus 9.7 molar. Great. So for some context for these particular things in terms of terminology, usually when people have a pH less than 7, usually we call this substance to be an acid, or that substance is acidic. If the pH is greater than 7, usually we call that substance a base, and we usually call that alkaline. So it's an alkaline substance that is a base. And if we have pH to be equal to 7, then this is a neutral solution. So it's neither an acid nor a base. And distilled water, so distilled water is an example of a solution with a pH of 7. All right, so let's just look at one more example of how to do these things. So let's assume we have a solution and it has a pOH of 1.36. So is this solution an acid or a base? So if the pH is less than 7, that means the pOH is greater than 7, right? So that means pOH is greater than 7. If the pH is greater than 7, that means the pOH is less than 7, right? So since that is the case that we're pretty much working with here, that means that the solution is a base, right? So our question, let's assume we want to know the concentration of hydronium. All right, so let's go through this process. Let's see. You may want to pause the video to see if you want to try this on your own. So we know that the pOH is going to be equal to 1.36. So that means the pH is going to be equal to 14 minus the pOH, so that's going to be 1.36. So that's going to be equal to 12.64. So if that is the case, one can find that the concentration of hydronium is going to be equal to 10 to the minus 12.64, which is really small, molar. And I just want to mention one more thing, so just a side note. So it is theoretically possible for the pH to be greater than 14 or the pH to be less than 0, right? So in the case that we have the pH is greater than 14, that would be highly basic or highly alkalic. And in the case where pH is less than 0, that would be our extremely highly acidic. But usually, at least on Earth, usually if we have solutions that have these extreme pHs, usually they do extreme damage. So they're not so common. And pH paper usually only functions well between 0 and 14. Same with electric nodes and stuff. But anyway, that's just some side notes and also an application of logarithmic functions. Hope you enjoyed. As always, if you enjoyed, please like this video, consider leaving a comment, and if you enjoy the channel content, please subscribe. We publish several new topics every single week. Thank you.